Welcome to lesson number 5, where we're going to be examining the sine law. We're just going to jump in and look at class example 1 and 2. Now, in each case, we want to determine the value of x to our nearest whole number. So here we're going to be looking for an angle, and if we're looking for an angle, this means we're going to have to use our inverse, one of our inverse trig ratios. So I have my side of my triangle that's opposite of my angle, and I have my hypotenuse, which is the side of my triangle that is opposite of my right angle, or my 90-degree angle, and also the longest side of my triangle. And so if I have opposite over hypotenuse, we're going to be using SOHCAHTOA, and using SOHCAHTOA, we're going to choose the correct ratio, which is going to be sine. Now, sine of x degrees is equal to opposite over hypotenuse. And the sine of x degrees is equal to 8 over 14. Now to find my angle, I need to use my inverse sine of my ratio. So sine -1 of 8 over 14. And the angle that I'll be given, so inverse sine, so second function sine, 8 divided by 14 is 34 degrees. To the nearest whole number, we'll just round that to 35 degrees. Next we have a side that I'm looking for, and I have my angle and I have my adjacent side to my angle, as well as my hypotenuse right here. So adjacent and hypotenuse, we're going to be using cosine. So cosine of 40 degrees is equal to my adjacent side divided by my hypotenuse, or cosine 40 degrees is equal to 19 divided by x. I can cross multiply my cosine 40 and my x, which means I'll have 19 is equal to, x is equal to cos 19 divided by cosine 40 degrees. And my value of x to the nearest whole number, 19 divided by cosine 40, is equal to 25. Now, in this next example, we want to use SOHCAHTOA again to determine the length of BC. So we want from this length, from that point to that point. So this vertex to this vertex. We want to work to 3 decimal places and answer to 2 decimal places. If we're looking for BC, then we're actually going to have to solve for BD, and then we're going to have to add DC to this length. And so if I find BD and DC, I'm going to have to solve 2 separate triangles. And so I'm just going to highlight the triangles I'm working with, first of all, to answer this question. So first I'm going to be working with triangle ABD, and then we're going to be working with triangle ADC. Okay, so 2 triangles we're working with. Now I'm going to start with my orange triangle. That's everything here in order to find this length, BD. Now in order to find length BD, and I'm going to be working, I'll work underneath of this triangle here. In order to find this length BD, what I need to do is consider the angle, the side I have, and what I'm looking for. So I'm looking for side length BD, and I have an opposite side. So that's opposite, and I have my hypotenuse, which means I need to use my sine ratio. So sine of 20 degrees is equal to BD over 12.50. Now, what I get if I need to multiply both sides by 12.50 in order to find my value, that is BD. So BD is equal to 12.50 times sine of 20 degrees. BD then is equal to, so 12 times sine 20 is equal to 4.104. So we're working to 3 decimal places. So 4.104 centimeters. And side DC. I now got to find side DC in order to determine what this length here is. And this time, I'm given 2 angles. All right, so I'm given 2 angles, and now with these 2 angles, I have to find side DC. Now this is the thing, I need at least one side in order to find this missing side over here. So what I'm going to do is I'm going to find out what this length here is going to be, and the only way to do that is to again use my orange triangle. So to find this adjacent side, we can use our Pythagorean theorem, since we have 2 known values now. Pythagorean theorem is equal to a squared plus b squared equals c squared. Now we have our c squared value, and we have another one of the legs of the triangle, so we'll have to rearrange this equation to be c squared minus a squared equals b squared. And c squared value is 12.5. My a squared value is the one we found earlier, which is 4.104 squared, and that's going to be my value of b squared. So I have 12.5 squared minus 4.104 squared. I get 139.407, which I need to square root, and I get 11.807. So that's my value of b. So 11.807. Now I can use this value in order to find out the length of DC. So I'm just going to write this in here, 11.807 centimeters. And then we have the option of using either 55 degrees or 35 degrees. So either 55 or 35 degrees. Now, I'm just going to choose arbitrarily. If I select this angle to use, then in order to obtain the length of DC, this is my adjacent side now, and then this is my opposite side. So if I have adjacent and opposite, then I need to use tangent. So my tan ratio is going to be tan of 35 degrees is equal to opposite over adjacent. And I'm looking for DC, which is my adjacent. So tan 35 degrees is equal to 11.807 over DC, which is what we're solving for. And again, I need to cross multiply these two, so they just switch places. 11.807 divided by tan 35 degrees, and DC is equal to 11, or second answer, divided by tan 35. DC is equal to 16.862 centimeters. Now, the length of DC, or sorry, from B to C, is equal to BD plus DC. So BC is equal to 16.862 plus 4.104, and we get a length of 20.97 centimeters. Now we're going to be looking at trig in obtuse angled triangles. So obtuse angles means that we have an angle that's bigger than 90 degrees. And if we have an obtuse angled or a non-right angled triangle, then we can't use SOHCAHTOA, and we can't use our Pythagorean theorem. So in those cases, we would have to use the sine law. Now, if I have an obtuse angled triangle, so if we look at this triangle, I have two acute angles, and then I have an obtuse angle that is larger than 90 degrees, and that's angle B here. Then we want to represent the length of the side opposite angle A, so the side length opposite of this with little letter a, lowercase a, the length of the side opposite of angle B by lowercase b, and the length of the side opposite of C with lowercase c. Now this is important to remember. Now the reason we use this is because this forms a ratio of A over sine A, B over sine B, C over sine C. And we can reverse that to say sine A over A, sine B over B, and sine C over C. Class example 3 is actually the same example as class example number 2. The only difference is the angle that we previously had separated to 20 and 55 degrees has been combined to give us 75 degrees. And we're going to use the sine law in order to solve this question now. Now, when we're labeling a triangle, to use this with the sine law, we would label like this, where if I have angle A, opposite of angle A, I would call side A. Where I have angle B, opposite of angle B, I would have side B. And opposite of angle C, I have side C. Now, with the sine law, we need to know 3 pieces of information, all right? So we either need to have 2 angles and 1 side, or 2 sides and 1 angles, or sorry, 2 sides and 1 angle. Now we have that. We have our A, we have angle A, and we have a side A, or we don't have a side A, that's what we're looking for. And we have side C and angle C. Now the way we set this up too is it works easiest if we have our unknown on the top. So our unknown here is A, because this is what we're looking for. We're looking for the length of BC. Now A is paired with sine A. Now sometimes we could pair A and sine A with B and sine B, but because we don't have either piece of information for the side or angle, we're not going to use sine B at all. Instead, we're going to use the ratio of C to angle C. And so our sine ratio is going to look something like this. Now, my side A, again, is unknown, so I'm just going to call that x. And sine A is equal to sine 75 degrees, which is equal to 12.50 divided by sine C, which was 35 degrees. Now, we have enough information we can solve. And in order to solve something like this, right away, we could pump this into the calculator as one calculation, or we could break it up. And if I break it up, I'd have to bring the sine 75 to this side of my expression, in which case I need to multiply both sides by sine 75 degrees, and over here by sine 75 degrees, multiply. So I can cancel it out. And so x is going to equal 12.50 divided by sine 35 degrees. And we're going to multiply this whole expression by sine 75 degrees. And you will see that my length of BC is going to equal our previous length of 20.97, which we were working with rounded numbers, but it should be very close. So 12.5 divided by sine 35, and we get 21.79. And this we need to multiply by sine 75. Oh, and that first one we got was 21.05. So 21.05 centimeters. That's our final answer. Now, differences in answers are due to us rounding earlier on. We were working to 3 decimal places before, and then we gave a final answer as in 2 decimal places. And usually you would just store your answers and work, but we were just going through the directions of the problem. So the actual length from B to C is 21.05 centimeters. Now, if you compare the amount of work you're doing using the sine law to the amount of work you're doing using the trig ratios and Pythagorean theorem, there's kind of no contest in preferred methods here. We're going to use the sine law in the triangle shown to determine the measure of angle ACB. So this is the angle we're looking for. I'm going to call it X. So ACB to the nearest degree. Now again, our unknown we want to have on top. So let's see what we have so far. Here's my angle C, and we don't have side C, but we do have this 9.4, and we have this side length 6 here, and we have 110 degrees. All right, so remember what we have here right now is we have a side A, we have a side B, and we don't have anything for side C and C. So before we begin, what we could do is find the measurement of angle B, because I don't have enough information to find the length of C or the angle of C. So let's set up our ratio, and what we're going to be solving for first is angle B. And so I'm actually going to have a different ratio set up this time. I'm solving for sine B, and the ratio is paired with side B, and that's equal to sine A over A. So notice how the way I set this ratio up is different than our previous example, and that's just because I wanted my unknown on top, and the unknown in this case is an angle. And so in order to solve something like this, now we'll plug in our known values. So sine B over 6 is equal to sine A, which is sine of 110 over 9.4. Now I need to get this sine B by itself. So sine B is equal to, and in order to do that, I got to multiply both sides by 6. So multiply both sides by 6. And when we do that in our calculators, we're going to get sine 110 divided by 9.4, and we get 0.09. Multiply that by 6, and we get 0.599. So sine B is equal to 0.599. But remember, we want to solve for the angle, and so angle B is going to be the inverse of 0.599. So inverse is equal to 37 degrees. Now we're looking for angle C here. So what we want to do is we want to subtract, remember all angles add up to give you 180 degrees in a triangle. So 180 degrees subtract 110 degrees, subtract 37 degrees. So 180 minus 110 minus 37 will give us 33 degrees. So angle X, or angle C, is going to be 33 degrees.